Hi, everyone. I just wanted to record a short video for you to look at one of your homework questions. So we're taking a look at question number 36, which is a straight up density problem. So in this problem, we're given that we have a graduated cylinder, which contains 1.40 liters of solution. We're told the density of that solution is 1.02 grams per milliliter, and we want to find the mass in grams of that buffer, of that solution. And so there's a couple ways that we can go about this. One is that we can use just the straight up density equation. And so remember, density equals mass divided by volume. In this question, we're given density and we're given volume. We're trying to find mass. And so we can rewrite our equation here and solve for mass. Mass will equal density times volume. We're given a density of 1.02 grams per milliliter. We're given a volume of 1.40 liters. We do have to note here, however, that we're given a density in milliliters. In order for us to use our density equation here, we have to make sure that our volumes match up, that our units of volume match up. So if we're given liters in our density equation, we need to convert our volume over to milliliters. Sorry if I might have said that wrong. If we're given milliliters in our density equation, we need to convert our volume to milliliters. And so 1.4 liters, there are 1,000 milliliters per liter. That's our milli conversion. And so this then will equal 1,400 milliliters. And so we then put that in for our volume. And so we get 1.02 times 1,400 equals 1,428 grams. We have to take note of our significant digits. If we look back at our original problem, we were given 1, 2, 3 significant digits in our volume measurement. Remember, this 0 is significant, it does count. We're given 1, 2, 3 significant digits in our density. And so our answer must then be rounded to 3 significant digits. And so we're going to round this to 1,430 grams. And so you could very easily solve the problem this way. Just manipulate your density equation, put the terms in, and multiply, and you get your answer. I wanted to force you to use dimensional analysis for this problem, though, and that's what the setup is here. Dimensional analysis, as I've talked about before, is an incredibly powerful problem-solving tool. And so there are going to be questions within Chem 101 that I'm going to force you to use dimensional analysis. Because the point of this question isn't necessarily to get the right answer. Yes, I want that to happen. But the larger point to this question is to teach you how to use dimensional analysis. Therefore, in questions like this that do use a dimensional analysis setup in Chem 101, even if you get the actual numerical answer right, if your dimensional analysis setup is incorrect, you will not get credit for the question. Now, it isn't just because that I want to be a jerk. It's because I do believe that dimensional analysis is such a powerful problem-solving tool that I want you to learn it. And so let's look at how we would set this question up using dimensional analysis. We're going to start with our given information. And so we're given 1.40 liters to start. Chem 101 gives us our numerical amounts in blue and our units in red. Note here that this is just extra information. We don't need this at all. This is just telling us the size cylinder that we're using. This is how much solution we actually have. Quite often when I'm doing these questions, I will then set up for my answer to at least drag my units down there. Shows me what I'm looking for, kind of the eyes on the prize, so to speak. Next, so I know that I'm going to need to use my density, my 1.02 grams per milliliter. But like we saw earlier, what I need to do first is to convert my volume over to milliliters so that I can use my density units that I'm given here. And so I need to convert 2 milliliters from liters. So I'll set my units up in there, and I see that liters cancels out, so that's good. I also know that there are 1,000 milliliters per 1 liter. And so there's my conversion for milliliters from liters. I'm going to add in another factor now to work with my density. I usually like to put my units in first. Density is grams per milliliter. And so I have to decide which way I'm going to use that, which way I'm going to write it so that my milliliters will cancel out. So milliliters needs to go down bottom and grams up top. And so now milliliters is canceling out for me. And it was 1.02 grams per milliliter. So the 1.02 goes with the grams per 1 milliliter. And now, sure enough, if I do this math out, 1.4 times 1,000 times 1.02, I come up with that same 1428. Round that for my significant digits, and what do you know? 1430 is one of my options for an answer. Let's check if we got it right. 10% penalty if I'm wrong, so I want to make sure that I'm correct. And there we go. Correct. There we have it. And so that's how you would use dimensional analysis to solve a problem like this. Let the units guide you through how to set things up. If you do that, you can get correct answers. Now, I know that I've said that a number of times, and a problem like this is a little bit simpler, but we're going to run into much more complex problems down the line in this class. And so even if you don't really understand the science of what's going on quite yet with some of these later problems, you'll be able to get right answers if you can use dimensional analysis. It is such a powerful tool. That's why I force you to use it early on in this class and on this platform. And so I hope that was helpful for you. And if you have any questions, make sure to send me an email or check out some of the resources that you do have on the website. Have a great day.